Hello everybody, welcome here to another video by JFB, and in this video we'll be looking at a special type of logic gate called XOR gate. You can call it XOR gate, XOR gate, any type of name, just try to pronounce it. I call it XOR myself, but I'll use a different name. The full name of this same type of logic gate we're looking at is exclusive OR. That's what it is, exclusive OR. So they just got the X from exclusive, put it there, and you have XOR gate or exclusive OR. What does exclusive OR gate mean? Exclusive OR is simply a logic gate which tries to emphasize difference. I'll say difference, or if I don't know if this is a correct word, exclusivity in short. It tries to emphasize difference or exclusivity. What do I mean by this? Before I dive into what I mean by difference or exclusive, let's look at how the XOR gate looks like. And by the way, the exclusive OR gate is made up of just the basic type of logic gates, which is the AND gate, the NOT gate, and the OR gate. Now in this video, I won't dive into how they're like set up and all that, because for the exclusive OR gate, it's actually made up of 4 NAND gates. And it's quite a complex circuit. I wouldn't recommend that you even try to Google it and all that, but you can Google it if you want. But you see, it's just made up of 4 NAND gates, whereby you have AND gates, or NOT gates, and OR gates just connected like that. You see that. Now let's look at the diagrammatic representation of the exclusive OR gate, which is trying to emphasize difference, or that you see. So it's drawn like an OR gate, but the only difference is that it has some sort of like curvature at the end and extra curvature at the end. And for it, it also takes 2 inputs and produces 1 output like all the logic gates. And by the way, there's a gap here. It's not like the wires cross through and all that. There's a gap there. So that's the exclusive OR gate diagrammatically represented. So you can write an XOR here. Why is this logic gate important? Well, it's used in many different types of circuitry. Like all other logic gates, it's used in circuits to make some logic in the circuit. That's all. Now let's look at the truth table of the exclusive OR gate, and this is where you see the difference between the OR gate itself and the exclusive OR gate. So let me draw an exclusive OR gate for you right here, like that, a curve, an OR gate without inputs. That's all. So a curve there, inputs, a gap here, then the OR gate itself. Then we're going to label this input line as A as usual, this input line as B as usual, and this output line C as usual. Let's now draw a truth table. And by the way, remember the formula 2 power x, where x represents the number of input lines you have. So I have 2 input lines. That means I'm going to have 2 to the power 2, which is equal to 4. And this 4 depicts the number of rows I'll have in the truth table. By the way, there are some logic gates which take even 6 inputs. That's why this formula is important, in order for you to determine the number of rows before you even draw the truth table. Let me fill in the table A, B, and C. There you have it. So we start with input set of 0, 0. So we have 0 on A, 0 on B. What do you think the output will be on C? That's quite easy. For exclusive OR, it obeys just one rule. The inputs should always be different. That's all. That's the only rule on the exclusive OR gate. When the inputs are different, it will give you an output of 1. That's all to it. When the inputs are same, it will give an output of 0. That's the only difference. So exclusive OR is trying to emphasize difference by simply saying I'll only be 1 when I have a 1 on one side and a 0 on another side. That's the only time I'll be 1. So when I have 1 on one side and a 0 on the other side, I'll give you an output of 1. Exclusive OR is trying to emphasize difference. That means the inputs should always be different in order for it to give you a 1. So in this case, 0, 0, the inputs are the same, 0, 0 on both input lines. What do you think the output will be? 0. As I stated earlier before, when the inputs are the same, 0. When the inputs are different, 1. So let me give you a scenario when the inputs are different. 1 on A, 0 on B. What do you think the output of this will be? It will be 1. Just like the OR gate, every time you give it a 1, it will give you a 0. But for the exclusive OR, you will see the difference shortly. So when the inputs are different, it gives a 1. What about in this case, 0 and a 1? It will also produce an output of 1 because the inputs are different. What about 1, 1? Typically, an OR gate will produce an output of 1 here because it says anytime you give me an input of 1, I'll give you an output of 1. Now for the exclusive OR, it's trying to emphasize difference and all that. So these inputs are the same. It's not only 0, 0 when they're the same, also when it's 1, 1, they are the same. And for that, the exclusive OR gate will produce a 0. So when the inputs are different, it's 1, 1. When the inputs are the same, it's 0. And that's all. There's nothing else about the exclusive OR gate unless that. So the exclusive OR gate, to summarize it all, is just made up of NAND gates, 4 of them to be exact. And all it does is tries to emphasize difference. So when they're different, it will give you an output of 1. When they're the same, it will give you an output of 0. That's all. That's the only difference. When the same, it gives you an output of 0. When they're different, it gives you an output of 1. And with that, we have finally finished looking at all the logic gates, which I think are very important for you to learn. Some logic gates are not even important here in terms of programming, but they can be used in other things like computer architecture, which will be a topic we will look at in future. But some logic gates like the AND, OR, and NOT, you see them in programming. They are coming back. These same terms will come back in a different form, but the main point will be the same. Just the same as they obey these truth tables, that's how they will be used in programming. And or NOT, these will be the main ones in programming. The others, NAND, NO, and XOR, will be used in computer architecture, how to build maybe a simple calculator and all that. So thanks for watching. Please leave a like and subscribe.